So I had a request on the channel for talking about how matrix multiplication works. Well, first let's see what a matrix does to a single vector. So what a matrix actually is it's just a recording of the matrix or a linear operation on the standard basis. And so 1, 0, 0, for instance, is going to spit out this first column. And then if you change it from 1, 0, 0 to say 0, 1, 0, these indices are going to change to 2 because it's just this column. And so then if you go ahead and replace 0, 1, 0 with a general vector, say C1, C2, C3, so you end up having C1 times the first column, or what you would get if you had 1, 0, 0 here, plus C2 times the second column, plus C3 times the third column. And what you'll notice is that each one of these guys here is really the vector dot product between this row vector and this column, which gives you this here. And so basically the first row, second row, and third row multiplied by this column here. But now what happens when you take two matrices and you multiply them by each other? So let's say we have two matrices, A and B, where A has all these little A elements and B has all these little B elements. If I'm trying to figure out what the matrix for M looks like, a matrix is just a recording of what happens when you apply this matrix to a standard basis vector. So if we're going to figure out what goes here, we need to multiply M times just 1, 0, 0. Then that means we're going to first apply B to 1, 0, 0 and A to 1, 0, 0. Then that means I'm multiplying B times 1, 0, 0, and that this ends up giving us B1, 1, B2, 1, and B3, 1. Now what we just saw when I multiplied A times that vector of C's, we ended up having the dot product between each one of the rows times this one column. So what ends up happening, if we take a look at the matrix applied to 1, 0, 0, which is going to give us our first column. And so this is our first column of our matrix, and this has our rows of A times our first column of B. And so that's what ends up going into our first column of our matrix M. And if you want to see what happens to the other columns of the matrix, well, that's just looking at 0, 1, 0, doing the same thing, where basically we extract this B and then we multiply it by the matrix of A, and then we go 0, 0, 1, where we extract the third column of B and multiply it by this matrix A. I'm saying A is equal to these column vectors, so A1, A2, A3 here, and then I'm saying that B is equal to these row vectors B, B, and B. So 1, 2, and 3. For each row, you have the row vector of A times the various column vectors of B, and yeah, that's matrix multiplication in a nutshell.